So, in previous class, we learned the quantum numbers. So, we have 4 quantum numbers. Number 1, principal quantum number, small n. Angular momentum quantum number, small l. Magnetic quantum number, small m. Spin quantum number, small s. So, the first 3, these are explained already. The fourth one is spin quantum number. So the spin quantum number is denoted by the letter S, and the spin quantum number proposed by Uhlenbeck and Gauss-Smith. Uhlenbeck and Gauss-Smith. Okay, so this quantum number explains the spin of the electron. The spin of the electron clockwise and anti-clockwise movements. Clockwise movements, anti-clockwise movements. Okay, the clockwise movement taken as positive. The clockwise movement taken as positive, and anti-clockwise movement taken as negative. Okay, suppose for example 1s orbital. 1s orbital. So 1s orbital means 1 indicates the principal quantum number, s is the orbital. What is orbital? The electron, the place of the electron in an atom is called orbital. So we have 4 types of orbitals, s, p and d and f. So this is a 1s orbital. Okay, so this box indicates the orbital. The first arrow mark, the upward arrow mark, right, like this. So this is a clockwise movement of electron. So this is a anti-clockwise movement of electron. Okay, clockwise movement, anti-clockwise movement. The clockwise momentum of the electron taken as a positive, the anti-clockwise momentum of the electron taken as a negative. So this the spin quantum number explains specially the spin of the electron. The spin of the electron. Okay, here the principal, once again, the principal quantum number proposed by Niels Bohr, it gives the size and energy of the stationary orbit. And the second one is angular momentum quantum number or azimuthal quantum number denoted by the letter small l. So it indicates the shape of the orbital. SPD of orbitals. It explains the shapes of S, P, D and F orbitals. And the fourth one is magnetic quantum number. Magnetic quantum number. The magnetic quantum number explains the orientation of the orbitals. Orientation. This is the orientation. This is called orientation. Orientation of orbitals. Orientation of orbitals along x-axis, y-axis and z-axis. Last one is the spin quantum number denoted by S. So this proposed by Uhlenbeck and Gauss-Smith, and it explains the spin of the electron clockwise and anti-clockwise. Clockwise movement is taken as a positive value, anti-clockwise movement taken as a negative value. Okay, the clockwise movement is represented by the upward arrow mark, and the anti-clockwise movement represented by the downward arrow mark. So if after these quantum numbers, we have to learn the shape of the orbitals. So we have how many orbitals are there? 4 orbitals. Number 1, s orbital, p orbital, d orbital and f orbital. So now let us see what is the shape of the s orbital. shape of s orbital. S orbital, shape of the s orbital. So s orbitals are spherical in shape. S orbitals are spherical in shape along their axis. Okay, x axis, y axis, and z axis. Okay, students. So what is the shape of s orbital? That are 1s orbital or 2s orbital or 3s orbital, whatever it may be. So, but the shape of the s orbital is spherical in shape. So, it is spherical. Okay, students. Now, in the next video, so we learn about the shape of p, d, and f orbitals. Okay, thank you.